I am Cagney Coomer, and this is my local edition. I knew I wanted to be a scientist when I was 8, since I was 8 years old. I used to watch the Discovery Channel and be like, oh my God, I'm gonna be a marine biologist and I'm gonna study sharks in the ocean. But the ocean is scary, so I decided to be in the lab instead. I gotta tell you my very first science experiment in college. That's like the best one. Okay, so my very first science experiment in college was actually to extract DNA from a plant cell. And the way you have to do it is you have to pour liquid nitrogen onto the cells and then crush them up real fast before they melt, right? But I'm pouring the liquid nitrogen, but when you pour liquid nitrogen, it bubbles. Like, it's kind of scary a little bit. So I'm pouring it, and a piece of it pops off on me, and I just dropped the whole liquid nitrogen container because I thought that my arm was going to freeze up or something. I was terrified. I was like, oh God, it's on me, it's on me. And then I just dropped all the liquid nitrogen onto the lab bench, and it like froze in a circle on the lab bench. That was my first science experiment in the lab. Even though I was in college doing science, like having a biology major, I didn't know I wanted to be a scientist. I actually wanted to be like a doctor or something once I had got in college, because in college they don't really talk about like what a scientist career would be like. And when you go into like a biology major, they kind of push towards showing you medical fields, introducing you to medical people. So I just always assumed, well, now that I'm in college and I have this biology degree, I'll probably go to medical school. So I think that actually having experiences of being able to work in labs, and so I worked in multiple labs. I've worked in the FBI in a fingerprint lab, I worked in a cell lab, I worked in a plant lab, I've worked with mice, and I've worked with zebrafish. And I think that working in a plant lab was the first time I ever got to do an experiment where I got to like manipulate something, wait for it to grow up, and then see what happens. And I was like, oh my God, you can do so many things to plants. It is unbelievable. You can genetically modify, like here in UK, they have a whole field of tobacco. The tobacco smells like roses because they genetically modified and put the pheromones from roses into the tobacco plant, and then the tobacco leaves smell like roses. They have a whole lemon field where the lemons don't have smell. They knocked out the gene that makes the smell. So because the lemons don't have smell, they also don't have no taste, because you need smell to have taste. So who inspires me the most? The kids that I work with at Nerd Squad inspired me the most. And the reason that they inspire me the most is because they believe in me so much. Like, I'm the only scientist they ever met, and they think that I'm like the most amazing rock star ever. Like, so to me, I have all these kids looking up to me, and they all tell me how they want to be like me, and it just motivates me to keep pushing and become the best scientist I can be. I think that actually in my job, the art of it is the microscope. How I genetically modify brains to grow green, and then I get to like sit in front of a microscope and take all these beautiful pictures of green glowing brains and green glowing eyes. I can make them glow all kinds of colors, not just green, red, yellow, green, like just a rainbow of stuff. And I get really excited when I get to the point where I get to actually get on the microscope and like look. I'm like, oh my God, look at these brains, they're blue. Everybody come look at this right now. That's like my life. That's how I react to everything. I chose genetic diseases because I'm a black person, and in the black community, you always hear about how black people are predisposed to all of these diseases, which means that when we're born, we're already like eligible to get that, but why? What about our DNA makes us more susceptible to all of this stuff? Like, that's what I'm interested in. That's like what I want to have a career, to understand how come we're always pinpointed to be susceptible to so many things when we know genetically our DNA is much stronger. So what about our situation puts us in that? Or is that even true? And that's the part that I really question, whether or not that's really true, whether we're predisposed to get to diseases, or if we're put in life circumstances that put us in situations that allow us to have these diseases more than other cultures. Was there a lot of support becoming a scientist? Yes, I had a lot of support, even though most of my support had no clue what that meant for me to be a scientist. Even like when I published my first paper this year, everybody's like, I'm going to read your paper. I didn't understand nothing it said, but I'm so proud of you. So yeah, I got like a lot of support in a lot of different ways. Have any experiments ever went wrong? As a scientist, all experiments go wrong, especially the first time you ever do any. When I first got to this lab, I didn't even know what zebrafish was. I had never even heard of a zebrafish before. And your very first job is to set up a cross, collect the embryos, and then collect them at different time points. So you gotta collect them at 24 hours, 48 hours, 72 hours, and then you gotta chop them up and show them to my boss. Well, I was all excited because it's the first time I ever did it, and I collected them, and I thought I collected them all at the right time points. But somewhere along the line, I mixed up the time points. So I chopped them up, and I took all these images, and I'm in my boss's office, and I'm like, look at this, isn't it beautiful? This is a 72-hour embryo. She's like, no, ma'am. I don't know what this is, but this ain't 72 hours. I was like, yes, it is. It was in the tube. She was like, you see this part of the eye? There's no cells here. There's no cells here. As a matter of fact, let me get on the computer. And she like pulled up a screen. This is what a 72-hour embryo looks like. I was like, that's not a 72-hour embryo at all. I don't even know what time point that is. She was like, I don't either. You need to start from the beginning. I was like, okay, I'll set up crosses and try again next week. So I think that was like one of the most humiliating mess ups ever, because she was looking at me like, what are you even talking about right now? My comeback was the next week. I didn't mix up no samples. I put them all in separate tubes. I lined them up evenly. Then I chopped them up and I took pictures, and I went in there and I was like, this looks just like it looked on Google. I Googled it before I brought it in here to you. This is a 72-hour eyeball. She was like, exactly. And you can see the cells and how they line the area. And I was like, oh yeah, it does. You're right. I had no clue that I was supposed to look for that the first time. You didn't even tell me that. I think the major struggle I deal with as a black scientist in this environment is vernacular. It's my language, because even though I'm intelligent, my vocabulary was probably 100 words when I got here. And I could use those 100 words to describe anything you needed. But in the science world, those 100 words do not fit the quota at all. And so about at least my first year, everything everybody said to me sounded like Japanese, because I had never heard 90% of the words that were spoken to me. And they were spoken to me so casually because everybody here is used to using them in conversation, and I'd never heard any of them. So it took a really long time for me to get to a place where I could actually dialect with other people in science and use their vocabulary. It was very intimidating as well, because you do kind of feel like you're inferior to people when they're using words that you don't know. My boss would talk to me and I would nod and smile, and then I would have to go sit in the bathroom and Google all the words she said to me so that I could know what she just said to me, because I would have no clue. And I was nervous to tell her that I didn't know what she was saying to me at all. Now that my vocabulary is starting to expand, because although it is starting to expand, it is a longer journey for me, because outside of work I have nobody to actually have conversation with to use my vocabulary or my vernacular. Like, I could have conversations with people I know, but most of those people are going to be like, I have no clue what you just said to me. So it's taken me a lot of like reading science, making science friends. Like, when I'm in the workplace, I try my best to always use the language that they're using. And when I first started at home, we would have word of the week, and I would learn a science word, and we would try to use it in every sentence that we had to help me just get to a place where I was using this language more often, so that it became more normal to me to speak and talk this way and not use slang, because, you know, I have a habit of throwing a little slang in with my science, and then everybody's looking at me like I just spoke Japanese. My advice to people who want to be in the science field and don't know where to start, I would say first be curious, ask questions, and take advantage of all the opportunities that are in front of you. I worked in the FBI lab because somebody literally came into my undergraduate class and said they were looking for interns. And I just raised my hand. I had no clue what to expect or what it was going to be like. I didn't even know if I ever really wanted to work in a lab at that moment in my life, but I was like, it's an opportunity. I just want to try it. Even getting here where I am today, this happened by just taking advantage of opportunities that were laid in front of me, because I didn't really have anybody to give me guidance, because I didn't know any other scientists. How did I become a published scientist? Well, research. So I spent the last 4 years studying this specific gene and its expression during development. And then I created this experiment where I caused damage and destroyed the retina. And then I studied the expression of that gene during that damage. And that data that I collected, I wrote a manuscript and I published it in the Investigations of Ophthalmology and Research and Vision Research. And that's how I became a published scientist. What does it mean to me to be a published scientist? The significance is sometimes beyond words. Like, I'm just a regular old girl from the hood, but I am definitely a published scientist. Like, you can Google me and my research is going to pop up. That is dope, okay? In my opinion, to me, that is the dopest thing ever. And in my community, most of the people that I know, I am the only scientist they know, but they know a published scientist. And most of the people in my community have read my manuscript, and they've probably never read a science journal in their lives. They've never seen anything like the stuff that I do ever before, but they've read it cover to cover. That is amazing. It's significant. And also, my research is novel. Nobody's ever done what I did. So for science, I am laying the foundation for studying this specific gene that could change the way we look at it, or the way we think about it, or the diseases that they cause. How would I describe my growth? I would say that when I came to graduate school, what I thought about what would be in graduate school is absolutely nothing compared to what I've experienced. I've grown intellectually in so many ways that it's sometimes unbelievable how my thought process is now. Like, it doesn't matter what subject or where I'm at or what environment, I'm always trying to figure out, well, how does that happen? Nobody can tell me something without my very next question being, well, how did that happen? What is behind that? How did you get to that space? Because that's all I ever think about when I'm here is how. Like, how did we get here? So now in everyday life, my thought process is always like, how? You can't just tell me something. I'll be like, oh yeah. And I'm gonna be like, what? How? How'd you make that happen? How does that do that? How does that work? And I've grown. Of course, I talked about my vocabulary. As far as my vocabulary has grown, I mean, I literally probably had 100 words. I know thousands of words. I know words that mean the same thing. I can tell you like 10 that mean all the same thing. That is like freaky weird, but that's really what I learned here. It was like how to speak in so many different ways because they push for it. And I also think that it taught me that I'm stronger than I thought I was. To survive in this environment and to be the only one, I literally have to like allow so many things to roll off my back, or else they would have been forced me to want to quit because of the situations that I get put in on a regular basis and the microaggressions that I have to stomach here all the time. I think those are the main ways I've grown as a person since I've been here. This is my most proudest. All right. So in order to publish a paper and be published in a high impact journal, like the journal that I'm publishing in, it has to be peer reviewed. My paper was peer reviewed by 2 people who are like world renowned in studying the gene that I'm studying. And my reviews were amazing. They were talking about how immaculate my work was, how precise it was. Like most people get their reviews back and they have to do like major experiments before they'll publish. All of my edits were just grammatical. Like, maybe you should reword it this way. You forgot this paper. Maybe you should talk about this paper here. It'll help draw your point. But other than that, I was peer reviewed, edited, and resubmitted within 2 weeks. That is pretty dope for a scientist. Sometimes my boss tells me that she thinks I'm intelligent, which is also really cool. But, you know, it's an ego thing, so people don't really tell you a lot. They don't ever tell you that you're doing good. You just do good, and then you're at the end. They don't really tell you that you're doing well. You just kind of wander around in the dark till you bump into something. It's kind of how it works around here. Earning my PhD means a lot of different things to me. First of all, it means when I walk in a room, people have to address me as doctor. And I'm gonna be doctor from the hood, cause you know, like, I'm just that girl from the hood whose parents was like drug dealers and drug addicts, and now I'm gonna be doctor of science. Like, having a PhD in the science is the highest PhD you could get, and I'm gonna hold that, so that's pretty amazing. But it also means that when my niece, who wants to be a scientist, thinks about it, she thinks about me and she pictures me. And when she pictures me, she knows this journey and she pictures it a Black woman. So she thinks that this is something she can do too. That changes the way she sees the world, because this is her idea, and now there's somebody who looks like her who represents something that she could see herself doing in the future. That's significant to me. That's more significant to me than even being called doctor. Where do I see myself in the future? Hopefully one day I get to have my own lab where I'm doing my own groundbreaking research, but I'm also getting to inspire and mentor and train the next generation of scientists, that I'm getting to breathe into them and uplift them and teach them how to use their brain as a tool. Because we talked about hustle, but like what my hustle actually is my brain. My brain is my tool. It's the thing I use. I know how to manipulate it and fine tune it the same way an athlete who runs track knows how to manipulate and fine tune their legs, or a wrestler manipulates and fine tunes their body. I manipulate and fine tune my brain that way, and hopefully someday I'll be able to teach all kinds of little Black girls and Black boys how to manipulate and use their brain as the tool that it is. I am Cagney Coomer, and this is my local edition.